Okay. Well, welcome everybody to the talk tonight. If you don't already know me, my name is Kathy Reese. I'm one of the co-founders of the Native Gardens of Blue Hill, and I'm currently serving as the part-time executive director. In the interest of keeping us on track with time, I'm going to hold off on making announcements and sharing upcoming events until the end of the talk, so please stick around for that. So right now, I'd like to introduce you to Spero Latchis, who is a certified soil health consultant and a certified lab technician associated with the Soil Food Web School. His interest in the life in the soil started when he and Robin Jameson moved to rural Himalayan India to open a charitable natural medicine clinic in 2009. While there, they began farming on 2 acres of compacted clay earth that received about 12 feet of rain every summer, which I can't even conceive of that. Anyway, to work under these difficult conditions, they studied the work of Dr. Elaine Ingham, and she taught them how to turn their dense clay into fertile, farmable soil. In 2017, they moved to Maine and founded the nonprofit called Living Soil Network. Spero has consulted on many soil restoration projects, both in India and in the US. Presently, he makes ecologically balanced compost with the Living Soil Company, consults on projects large and small in the northeastern US, as well as volunteering his time on the many charitable activities of the Living Soil Network. He'll be hosting an in-depth compost making workshop in May for Native Gardens of Blue Hill and the College of the Atlantic. So as a prelude to that workshop, today he will be providing an introduction to life in the soil. So with that, I think Spiro, you can take it away.
Mm. Thank you, Kathy. Um, I'd really like to thank you and Native Gardens of Blue Hill and College of the Atlantic. Just even kind of sponsoring this and hosting this, doing this work is really it's wonderful and it's groundbreaking, I suppose, as I could use that word. But you're really leaning into this, and it- you're right ahead of the curve here because this is going to become, I think, really important. And I've been giving talks for the last 7 years around Maine, and we were at the Common Ground Fair, I think 6 years ago, our first talk, and most of the people had like blank expressions, and they were like hadn't heard anything about this. They didn't know what we're talking about. They were just kind of, oh wow, okay. Last year when we went, we had full tents and people were present, their eyes were open, they were nodding their heads and going yes during the whole talk. So there's a huge change that's happening in the consciousness about living soil right now. And it's really exciting to be doing this work and to be sharing this making of this compost with people. So um, yeah, anyway, I'm very excited to be involved. So before we start talking about compost or any of the details, I want to just step back for a second and talk about our assumptions and our views of how we approach this material, because this is so critical. If we approach making compost and using these biological soil amendments as if we were just adding one more thing or doing one more thing, we're going to miss the point entirely. It's not going to work, and we're not going to understand what this is all about. So I'm going to put on just this slide. I love this slide. So this is two views. When you put on these glasses, and these are the glasses of holistic thinking, of kind of global awareness, and of working with nature as opposed to working against nature. And when we can do this, when we can actually understand this process and work with nature, the result is abundance, it's life, it's fertility, it's health, happiness, joy, all the things we want, all the things we're trying to do as humans, right? Um, it's actually pretty simple. If we can learn how to work as a part of nature and not opposed to nature, and not separate from nature either, then we can really have some abundance. Now, the opposite of that is this: it's scorched earth, it's famine, it's drought, it's disease, pestilence, war, aggression, all the things that humans seem to be doing now with great abundance. Um, and it really stems from this view of this reductionist model of reducing nature down to its parts and then trying to manipulate those parts. So we're talking about something different. So let's just look at why all of us have some of this view. All of us have a certain degree of wanting to control and fight against nature. Now, why? Because of this, we're terrified. We think Mother Nature is trying to kill us. On some level, our mother, the earth, is actually trying to kill her children. So this is a little bit questionable, this attitude, right? Doesn't really get us very far. So what is our response to this state of mind? This is our response. Control. We try to control our environment. We try to control our soils if we're working with soil and with plants. If we have a garden, we want it to be perfect. We don't want one weed in there because weeds are deadly and toxic. We have to get them away from the garden. If there's an insect, we have to get it out. Everything has to be controlled, neat, clean, perfect, and under our power. This doesn't really lead us to a good place, this attitude. I'm sorry, it doesn't. So, what is the opposite of this? Well, we can do this. We're in nature and we're just breathing in the bliss and the sun and all the butterflies are around us, and we're smelling that looks like ragweed or something growing here. I don't know. But we're bringing in the smells and we're just so happy. Well, this is another extreme view. Because if we do this, then we have to deal with the reality of this guy, which is Siberian tiger kills man who followed predator's tracks after dragging away and crushing his dog. He followed the tiger and the tiger ate him. So tigers do exist in nature. Nature, when we work with nature, it doesn't mean just bliss and one, following the butterflies, because those butterflies are actually eating and being eaten by other things. Everything in nature is a continuum of life and death, of birth and death. And if we reject that whole package, we can never understand how to really work with nature. We just either tripped out on the bliss or afraid of the potential disasters. So how do we find a middle way here? And I think the middle way is represented with this young person who has something what we call biophilia, which is a love of nature, a passion of nature, the inquisitiveness of the natural world, trying to understand and learn with an open mind, without fear and without ignorance, but learning. And I don't mean scientific learning, but learning from our heart and trusting our intuition as well. So learning in many different ways, whatever way we're open to, about how nature works, and with an open, clear, fearless mind. And when we do that, we come to this trusting the process. We can understand how things work, and then we can begin to really trust a lot more. So, and the foundation of this really comes down to the Gaia hypothesis, which is really that it posits that Earth and its biological systems behave as a single entity. This entity has closely controlled self-regulating negative feedback loops that keep the conditions on the planet within boundaries that are favorable to life. So this idea uncovers the entire planetary system, and that there's some kind of biological processes that are actually keeping the planet in a kind of the Goldilocks zone where we can live and life can be supported. So we're going to kind of tune in on this Gaia hypothesis into the soil tonight a little bit and look into the soil, talk about the soil ecosystem below ground and the above ground ecosystem. And as my really good friend Didi Perso says, plants are what join heaven and earth. They join the earth of the below ground ecosystem with the heaven of the above ground ecosystem in the atmosphere. They join those. So having said that, I want to look at this slide and ask the question, is this healthy soil? Now, we could say if you're a soil chemist, you could say absolutely. We have all the major soil minerals we need and even some of the smaller ones, the micronutrients. We're going to grow great plants if we have all this stuff in the right proportion. This is what healthy soil means. However, from a biological point of view or an ecological point of view, we have no idea if this is healthy soil. This could be sterile. You're going to have no biology in the soil. We don't know. So we can't really answer the question. So now let's go into composting a little bit. So composting, ecological alchemy, compost from death to life. Now, compost, so what is alchemy? What's the definition? A seemingly magical process of transformation, creation, and combination. So when we make compost, we are taking material that is basically dead, has just died, is no longer living, it's no longer growing, it's dying and will soon start decaying. Now we take that dead material and turn it into the most abundant living substance that we can possibly find. We're taking something that is dead and creating something that is so full of life and so full of possibility that the entire planet revolves around it. I'm talking about microbial health. So we take this, we do our process of moisturizing, aerating, combining, getting the microbes to start to do their thing, to decompose that and turn it into this. Now, what is this? This is actually not a picture of compost, but this is a picture of what happens to soil when you add balanced, ecologically balanced compost to the soil. Soil, so what we have here are colonies of bacteria. And there's our, tens of thousands or maybe 100,000 million bacteria in each of these little microaggregates. Now, this is at 400 power under a microscope. We're seeing, you can't see this with your eyes. So all these little bacteria form something called microaggregates. And inside these microaggregates, there's all kinds of air pockets. And these bacteria have very powerful glues. They glue to the sand, silt, and clay particles, the organic matter, and they form their own structures, their own homes, their own colonies so that they can exist, their own infrastructure. And what happens then next is that this guy, the fungal hypha, which extends all through here, comes along and combines these microaggregates into something called a macroaggregate, which is this one big circle here. Now, if you notice, you see all these air spaces between the microaggregates. The macroaggregate is what really gives the soil its most expressive definition, because this soil, with full of fungal macroaggregates, is 65% air. Now, just think about that for a second. What happens to your soil when it's 65% air? What happens? First of all, it creates an aerobic environment, which means an aerated environment. When you have an aerated environment, and the image here is of a soil sponge, and that sponge can hold water, and it can drain water, both. So it holds the right amount of water so the microbes can live. It doesn't flood them. It keeps the environment aerobic because of all the air pockets, and allows the plant roots to go down through all these air spaces to go very deep, deep in the soil. And as the plant roots go down, the microbes follow them. And what happens is then the soil becomes rich, rich, rich down very deep in the soil, which allows the plants to get water from deep sources and the nutrients from deeper. So the microbes create soil structure and they create an environment for themselves and for the plants to live in. Now we're just looking at a couple of these characters. This is a fungal hyphae, actually a number of them. Um, these are critical. Here is a fungal eating nematode. This guy with a sharp spear pierces through the fungi and eats the fungi. Now this guy's really good because we want to have nutrient cycling going on in our soils. These are testate amoeba. These guys eat 10,000 bacteria a day. So they reduce your bacterial populations, but more importantly, what comes out of, they can only take in 20% of the nutrients from bacteria. So 80% of what they consume is pooped out in the form of plant available nutrients right at the plant roots. So when you have enough of these guys in your soil eating the bacteria, you have tremendous amount of nutrient cycling and the plants just go crazy. Here's a little bigger picture, the soil food web, protozoans, nematodes, earthworms, microarthropods, macroarthropods, birds, animals form this entire ecosystem. When we talk about healthy soils, we need to talk about the entire healthy ecosystem. It's not enough to talk about we have biology in the soil. That's not enough anymore. It's not enough that we have earthworms, not enough that our soil looks rich. If we don't have this full ecosystem in there, our plants are not going to be fully happy. They're not going to grow. They're not going to produce the kind of um, produce the um, the immune system responses that they need. And the only way they can do that fully is to have all the micronutrients that this ecosystem provides them. So now we have to talk about compost. So what is in your compost and how do you use it? So this is the question of this evening and what we're going to talk about and do during this workshop. And why do we have to have a special workshop to make special compost? Why can't we just use our backyard compost or go to the store? There's a million people selling compost. Why is this stuff different? Because most commercial compost has evolved from the waste reduction model and does not contain nearly enough fungi or enough soil organisms to bring about healthy change. In fact, most of it is so heavily bacterial that it only reinforces the existing bacterial imbalance in most of today's organic soils. So what does that mean? That means because the way people are making compost, are not making a full ecosystem. They're not making a microbial inoculant. What people are making is plant food. When you buy compost, you're buying plant food. What you're buying is material that will slowly break down in the soil and provide nutrients from that material itself to the plants. The other type of compost can also be plant food, but it's much more than that. What the function of microbial complete compost is to add microorganisms into the soil so that those microorganisms are the ones that go out into the sand, silt, and clay particles, into the organic matter, and extract nutrients from those particles and bring them to the plants. This is a very, very different and fundamental change of perception and change of paradigm. So this is why you can't just go buy compost. So I would say, if you have a friend from New York City who's never been out in New York City, all they know is to go to Central Park once in a while in the afternoon, and they come up to Maine, you take them for a walk in the woods, and they look around and go, look at all the animals in this forest. Look, this is a great thing you have. Look at all the animals here. And you look and you see, well, I see a lot of squirrels, but that's all. There's no other animals in that forest. Now, you would think that forest is not healthy. It's not, there's no ecosystem going on there. There's no predators of the squirrels, only lots and lots of squirrels. So what's going to happen to that forest ecosystem? It's going to collapse if it doesn't get predators. The whole ecosystem will fall. Because without predators, without those tigers, we are not understanding how nature works. So let's go on one more. So the main problems in our soils, again, are that they are bacterially dominated. There's a lack of soil predators, and especially fungi, and fungi. Fungi are not predators, excuse me. And compactions means shallow root depth. So our goal as soil regeneration people is to break up that compaction and add microbial inoculants. And then our plants will be really, really happy. They will produce those super healthy immune systems that can ward off almost all the pests and all diseases. Um, so that's a lot of what I had to say. I want to show you some pictures here. Now, can you tell which compost? I took these this morning. Um, one from our compost. I just took a sample from our compost, and someone gave me a commercial compost, and I just put it in the microscope, took a couple of quick snapshots. These are at 400 power. So is it clear which, from the looking at microscope view, which of these um, is the biologically living compost and which is the sterile or dirt compost with not much life? If you look carefully on the right, you see a lot of little, black stuff here. Now these are some of the bacterial microaggregates are in the compost, and that's good because that's the first thing that happens. But that's pretty much all you'll find. And I've looked at this material under the whole a whole slide of it. I saw maybe one little piece of fungus, no predators, no nematodes. Um, there's a lot of organic matter, which is this and this and this. There's a little piece of actinobacteria here, lots of organic matter, but it's compost, which is made up of organic matter. So you should see a lot of organic. If you don't see organic matter in the compost, something really wrong because it's made of organic materials. So there's a lot of that. But organic matter, again, is not a soil ecosystem. There's so much emphasis on getting organic matter into our soils, more and more organic matter, 8, 10%, 12%. You could add all this compost in your soil and it's all organic matter, but there's hardly any life in it, only bacteria. So organic matter alone is not going to do the trick. Over here, we have, look at all the fungal hyphae growing out of this piece of organic matter, and it's only in one focus in one plane. You only see some of it. There's actually more fungal hyphae growing. Over here, we have a testate amoeba that eats 1,000 bacteria a day. We have lots of different shapes of bacteria all through here, although they're not in focus, but there's a variety of diversity of bacteria. So if I look at every single field of view in this microscope slide, which is maybe, I think, if I remember 2000, I'm going to see fungus in every single field of view. And over here, I'm not going to see any in this one. So there's a huge, huge difference in these two materials. This one is plant food. This one is microbial inoculant. So why do we need to do this again? We'll go back. Because really the future of the human race and of this earth depends on how each one of us engages with our soils. If we don't have healthy soils, this is what starts to happen. And I think at the figure now from the Savory Institute is 70% of our soil on Earth is either desert or rapidly becoming desert. So this is not hyperbole. Over here, we have lush green picture of a field and trees, and we have abundance. So the more we can do this, the better. And making really good compost is the fastest, the quickest, most efficient way of going from this to this. So I think that's all I wanted to say, and we can have plenty, some time for questions for sure. If anyone has questions, I don't know. Um, I'm not sure how to call on people.
Should we stop screen sharing and then we can see
Yes,
everyone?
yes,
Yeah, that would be good.
I can do it. Well, I'll try.
Also,
Yeah.
if people want to ask questions, I think we could just unmute ourselves and go ahead and ask. That might be the easiest way.
Sure.
And I'll watch the chat if anyone feels more comfortable putting it in the chat.
Yeah. Uh, okay.
Looks like everyone's muted still. Oh, here comes someone. Ray.
Yes, hi. Thank you for that talk. I just was wondering, hold on, let me just do the video as well so you can see me.
Ah,
So
yeah.
how do you know that how do you get the microbial nutrients or the inoculant into the soil? In other words, what is your source?
The compost. That's where we make it. The
Okay.
compost has all those players that we need in the compost. And we add it to the soil. And there's different methods of doing this,
Okay.
right? And sometimes we'll add more microbes than others. Like if we have a very bacterial soil, then we'll make a concentration of the predators and add that into the soil so that then they really start consuming the bacteria very rapidly.
But that's what I'm saying. Where do you get these concentrations of the amoebas and the nematodes and stuff like that?
They're from nature.
From nature.
Yeah.
Okay.
This is why we have to source good material. So you have the diversity of material that has all these things living on it, around it, right?
Okay, good. And my last question is, how do you know that I mean, is this only for gardening or can this be used for food production as well?
Well,
These inoculants,
all
are they
plants,
safe?
yeah, all plants grow from soil and microbial activities. So any plant, this is how plants grow. If you look in the
Okay.
forest and see trees, right? How do they grow? I mean, do you have do you know?
Okay, thank you.
Okay.
Okay, we also had a question in the chat that sounds similar to what Ray asked. How does one inoculate the soil? I'm not sure if there's anything more you want to say about that, Spiro.
Just there's different techniques. So, some of the times, if you actually have enough organic matter in the soil, at least 5%, then I often don't add more compost directly. I'll extract the microbes out of the compost into soil, into water, into solution, and add the water with the microbes. Because we don't need more organic matter and it stretches the microbes further. It's very direct, quick application. Um, and then we also can make compost tea from the microbes. It's a foliar spray. So there's 4 or 5 different ways of affecting the soil ecosystem using the various products that we can make from this compost.
I had a question. This is Terry.
Mm.
Can you hear me?
Yes, I can. Hi, go ahead.
During the winter, what is the process? What happens to these microbes? Do
Mm.
they hibernate and then come alive when everything thaws? Or,
Yeah.
are new ones created in the spring when
Um,
the temperatures rise?
well, both, right? So the populations of microbes in the soil are constantly changing from day to day, even week to week, depending on the temperature of the soil, the moisture levels. Um, so in the winter, so microbes have what let me back up for a second. In this compost, we are seeking to have 75,000 species of bacteria, 25,000 species of fungus. That's our ideal. So the reason we need that great diversity is that each of these species of microbes turn on and off. They they come alive, they function at different temperature ranges, different moisture levels, different times of the year in association with different plants. So we want to have a very diverse microbial ecosystem that we add to the soil. And then we're going to let nature sort out which ones turn on and off. Some of them survive the cold. A lot of them do, actually, especially the bacteria. The fungus actually grow very, very well just under the surface of the snow where there's snow melt during the winter. Um, so that water is dripping as the snow is melting. Then the fungus grow really well in that environment. Um, so it's complex. Yes, some die, and then in the spring, when the moisture levels come, the temperatures rise, more come back to life. They go dormant. They come to life. We add the plant roots, which start to feed them, and then they really grow.
Okay, thank you.
Hope that
So
makes some sense.
there's
Okay.
another question in the chat, but before we get to that, since it's 6:30, I don't know if Kathy, if you wanted to say anything about the next part of the series, and then we can take any final questions.
Yeah, I guess I will just take a moment and then we can have some final questions after that. So this was just an introduction to the idea that of looking at soil through more of a biological lens rather than a chemical lens, which we've sort of been trained to do using chemical tests to see what we need to add to our soil. This is a way of looking more of the life in the soil, the biology, and then so this is the first step, kind of like adjusting our way of thinking. And we'll be this is all leading up to a much larger workshop that's going to happen in May. So on May 3rd, the morning of May 3rd, we'll have I think about 4 hours of more detailed, in-depth presentation on the life in the soil. And then on the afternoon of the 3rd, we'll build a compost pile at Native Gardens of Blue Hill. And then on the morning of May 4th, we'll build another compost pile at College of the Atlantic. So as a prelude to that, we need to gather a lot of materials and get everything ready to create the compost piles. So we're looking for people who want to participate in the materials gathering and preparation ahead of time. So if you want to participate in the final workshop as well as the materials gathering, you should sign up for the workshop itself and also express your interest at that time in participating in the materials gathering. So we're going to try to gather on April 14th at 6 p.m. on Zoom to hear from Spero what we need to gather, both the compost materials themselves as well as the supplies we need to create the compost pile. And then we'll try to divvy up responsibilities and gather everything together, both at Native Gardens and at College of the Atlantic. So please go ahead and if you want to go ahead and sign up for the workshop, it will be $100 per person. This is like a whole day's worth of a workshop. And there we do have available some scholarships to pay for part of the tuition for the workshop. So this is like information that's really important. As like Spero mentioned, he produces compost that can be used as inoculant or compost tea. It's kind of the first step in getting these resources in our area, because personally I'd be happy to purchase living compost from somebody rather than make it myself. But anyway, so I think with that said, if there are any more questions, Spero, do you have a moment to stick
Yeah,
around?
sure. Yes, whatever.
So we have 3 questions in the chat. So anyone who'd like to stay on for these, I'll just go through them one at a time. And anyone who needs to leave, we understand. Do you ease compaction by mechanical means, or does the soil life loosen hard clay?
Good question. The soil you won't break up compaction without one-time tilling or using mechanical means. But when you do that, at the same time you add microbes behind that plow. Yeoman's plow, or a keyline plow as it's called, is the best way because it goes underneath and shatters the compaction layers from underneath the surface. So it doesn't till the surface of the soil. But there's only one of those, I think, in Maine. But there's other ways in gardens. We have injectors and ways of penetrating the soil and getting the microbes beneath the compaction layer. But once that happens, that starts to get in and break up. So what we did in our farm in India, we had a really strong young guy with a steel rod, and he hammered it into the clay because we had solid clay soil with 12 feet of rain. And he would hammer that down in 3 or 4 feet. We'd pour the extract in there. We do that every 3 or 4 feet around the whole farm. And within 2 years, that clay was flocculated. We could grow carrots that were 12 to 14 inches long. The first year they were an inch long. We had daikon. We thought we would use daikon radish to break up the compaction before we knew about this. And daikon radish stuck up about 16 inches out of the top of the surface, and the tap roots just went down about 4 inches. So um, so we need to really kind of use mechanical means.
Okay,
Yeah,
great. We have a question from Joshua who says, Spero, great stuff. Thank you. I'm trying to get a liquid compost operation going. Should I go aerobic or anaerobic?
that's a big question. Um, right. You're going to get a lot of different answers from a lot of different people about this one. What I was taught and what I have found to be true in my experience is that we want to keep our compost tea as aerobic as possible. Because once you start to put anaerobic microbes in compost tea, that's when you get really nasty things that will kill your plants and even kill you, such as spirochetes. I mean, the most deadly microbes are anaerobic microbes. I mean, sorry, anaerobic pathogens. They're all anaerobic. Aerobic microbes are not dangerous. This is why they're allowed. This is why we use aerobic compost teas. Um, Now, some people are using teas as basically um, um, enzymatic agents. When you're taking comfrey and all that stuff and fermenting it into a tea and making it anaerobic, or at least facultatively anaerobic, partially anaerobic, you're basically getting the enzymes extracted from those plants and applying those to your crops. That's a very different thing than applying microbes, beneficial aerobic microbes. Um, and I would be very careful about, I would never do that myself. I would never do that because I have aerobic microbes that I know work, do the job. I wouldn't want to risk going anaerobic. And especially with compost teas, I actually advise people not to do compost teas unless you have a microscope and you're willing to check your tea before you spray it. I always check the compost tea with a microscope because it can go bad. And when it goes bad, it goes really bad. It can. Um, and it takes about um, 20 minutes in a compost tea that's gone anaerobic to kill all the fungi. They disappear. You can look at your compost tea and see all this fungus. 20 minutes later, it's all gone. And you go, what happened? If you have too much bacteria in your compost tea and not enough oxygen to mix wrong, the aerobic bacteria grow so fast that they use up all the oxygen and creates an anaerobic environment, which crashes the fungal population. It goes aerobic again later, but at that point, you wiped out your fungi, which is the whole point of having beneficial compost tea is having an ecosystem, especially beneficial fungi, because those are the ones that coat your leaf surface and protect your leaves from fungal pathogens like like the things that get fruit trees or rust or um, powdery mildew. If you get fungal compost tea on your squash plants, your cucumber plants, the powdery mildew can't get in. So anyway, that's a long answer.
Yeah. Okay. Well, that sounds
Okay.
like an important topic to, you'll probably talk more about that in the
Yes.
next
Yeah.
session. Somebody does have a question about, you mentioned about needing a microscope. Someone did have a question about how you determine the microbial balance without a microscope.
Mm. You don't really, honestly. Um, what I'm going by, when I'm going to give you guys is a recipe I know works. I've done it a lot. I'm sure if you follow this, you're going to have good compost. And then you'll send me a sample and I'll look at it to be sure. Right? And unfortunately, it's a quantitative approach rather than qualitative. You can get a lot from just looking at the microscope, looking and seeing, do you see a lot of fungus in there? Do you see bacteria? Do you see the predators? Then yeah, okay, this is looking pretty good. If you want to know the ratios, the actual we call fungal to bacterial ratio in the compost, then I need to run it through a program and I need to do a more quantitative analysis, which you have to be trained to do that. But anybody who can use use a microscope can do very simple qualitative analysis of their compost or their soils.
Oh, we've got in the chat, Kathy.
Um,
Yeah, I think that's it. Um, Okay, well, thank you. That was very interesting. I hope it got everybody excited to learn more and participate. Um, Personally, I know that I'm not making great compost by just throwing everything in a pile and waiting a year or so. Sometimes that's all we can do. But anyway, I'm excited to learn how to make really like a whole ecosystem here. And I think this is a great opportunity for us to uh, be restoring our soils, which pretty much every soil around here needs some form of restoration. That's the unfortunate truth. So,
I just want to say one thing. Plants want to grow, right? They want to live. All life forms want to live. They're going to do the best they can, whatever environment they live in. So when you look around, you see, well, the plants are growing. I have a garden. Everything's good. I have a lot of tomatoes. All my plants are healthy. Yes, that's because plants adapt. They want to grow. But we're used to seeing, um, when our definition of plant health is the absence of disease. So we see something that's not sick, we think, oh, it's healthy. But there's actually much more than that. It's the same with humans. If somebody's not sick, are they healthy? I would say not. Somebody who's healthy is healthy. That's a different thing from not being sick. It's the same with plants. So we're trying to get healthy plants, vibrant, healthy plants that nourish us, nourish the planet, and do all kinds of amazing things that I didn't talk about with our above ground ecosystem and the planet and the climate. That's a whole nother topic. So anyway, thank you all for listening. And I hope a lot of you come and because this is really, really rewarding stuff when you do it and you see the results when you put this in your soil and your plants start to thrive and they're going to speak to you and go, thank you very much. So,
okay, well, we're looking forward to learning more. And I'm just going to make a couple little of announcements of things that are going to be going on here at the Native Gardens. On Saturday, April 12th, we'll have Springtime in the Garden with A.V. Clare, who's going to be talking about plants and practices for springtime. Our first volunteer day is Friday, April 18th. And Tuesday, April 22nd, we're having a screening of the Buzz on Native Plants at the Liberty Library. And again, on May 1st, we're having a screening at the Camden Library. And then, of course, the May 5th and, May 3rd and 4th are the workshops I just mentioned. And then on the 8th of May, we're having an Analyzing Your Site workshop led by Charlene Gray. And then we have the plant preview for the plant sale on May 15th. And then we're having an opening trail ceremony on May 17th. And then the plant sale on May 31st. Okay, so all those are pretty much available online. So just check the website if that went by too fast. Okay. All right. Well, again, just sign up for the workshop and let us know if you want to participate in gathering materials, and we'll get you on the Zoom on April 14th, and we'll take it one step at a time. And so thank you very much, Spero, for this information, and we're looking forward to hearing more from you.
okay.
Thank
Thank you.
you.
Bye-bye.
Bye, everyone.
Bye, everybody.
Bye.